Hi, this video is counting towards Unit 7, Lesson 1. Now, some of you might have Unit 7 skipped, and that is simply because we have not done all of the units so far, but we've kind of skipped some I still want to do this week for a review of what we have learned. So this video will be covering Unit 4, which is all about water on Earth. It'll be reviewing Unit 5 about weather and weathering, and it will be reviewing Unit 6, which is about rocks and minerals.
Greetings! I'm Explorer Dan, and this is my plane I use to explore and learn. After completing this course, you will be able to identify the 4 parts of the water cycle. They are evaporation, condensation, precipitation, and collection. The sun heats up water in rivers and lakes and turns it into water vapor or steam. The water vapor or steam leaves the river, lake, or ocean and goes into the air. This is called evaporation. Water vapor in the air gets cold and changes back into liquid to form clouds. This is condensation. When the clouds get big and heavy with water, they fall back to Earth in the form of rain, hail, snow, or sleet. These are all known as precipitation. Collection is precipitation collected in oceans, rivers, lakes, and streams. Evaporation, condensation, precipitation, and collection together form the water cycle.
Anytime you look up into the sky, you may see clouds. But no two clouds look alike, and some look very different from each other. So, what makes clouds? And why do some clouds look thin and wispy, while others look big and fluffy? Clouds are formed by water vapor in the atmosphere that condenses into very small water droplets or ice crystals, and then gathers together. When water on the earth evaporates, it turns into invisible vapor that rises until it reaches colder air high in the sky. In these colder temperatures, the vapor condenses or changes back into a liquid. Eventually, the water droplets will fall back to Earth as rain, snow, or ice. This is known as the water cycle. There is always at least some water vapor in the air. Clouds only form when the atmosphere cannot hold any more vapor. Since warm air can hold more water vapor than cool air, clouds are often formed when the temperature cools. Although they may look light and fluffy, clouds are actually very heavy. A single cloud may weigh as much as several million tons. They do not fall because warm air currents push up against the tiny droplets, and individual droplets are not heavy enough to overcome the resistance of the air below them until they join together into much larger drops. There are 5 basic types of clouds: cirrus, stratus, stratocumulus, cumulus, and cumulonimbus. Cirrus clouds are high and thin. Because the air is so cold at high altitudes, these clouds are made of ice crystals instead of water droplets. Cirrus clouds are sometimes called mare's tails because they are shaped something like the tail of a horse. The appearance of cirrus clouds often means a day of fair weather. Stratus clouds are shaped like flat sheets. They may occur at low, middle, or high altitudes. When stratus clouds layer thickly, they may produce light rain or snow. Cumulus clouds are puffy and small when they first form, but they may grow into much taller cloud formations. When lit by the sun, cumulus clouds are bright white and are often seen on days of good weather. Cumulonimbus clouds are thunderclouds. Heavy and dense, they are very large and similar to cumulus clouds. They may produce lightning, rain, hail, and tornadoes. Different types of clouds can indicate different kinds of weather, but aside from that, identifying clouds is fun. Next time you're outside, look up and see if you can identify the clouds where you are.
This is Earth, home to 7 billion plus people, 7 continents, and all kinds of amazing plants and animals. This is what Earth has looked like for a long time, and will probably continue to look like for a long time, right? Yes, and no. Sure, this is what Earth looks like from space, but even though it looks pretty much the same from whenever we view it from afar, once you zoom in on it, you can see it's always changing. On a small scale, things like moving water shape the Earth's landforms, the natural features of the Earth's surface. On a bigger scale, the gradual shifting of the Earth's crust is slowly moving even bigger things, like the oceans and the continents. So one day, our planet will look different, maybe a lot different from how it looks now. So how exactly does water shape Earth's landforms? Or to bring it back to the spheres we've been talking about, how does the hydrosphere affect the geosphere? To understand that, we need to discuss weathering. I'm not talking about the weather, like if it happens to be sunny or cold or foggy outside your window right now. I'm talking about weathering, the process that takes place as rocks and other parts of the geosphere are broken down into smaller pieces. Weathering can be caused by water, air, chemicals, plants, or even animals, including us. And there are 2 types of weathering you need to know about: mechanical weathering and chemical weathering. Mechanical weathering is the process of breaking big rocks into little ones. Frost, ice, the roots of plants, running water, or heat from the sun can all cause mechanical weathering. Chemical weathering involves the changes that some substances can cause in the surface of the rock that make it change shape or color. Things like carbon dioxide, oxygen, and acids can all cause chemical weathering. And when rocks have been weathered and all broken down and are later moved by natural forces like wind, water, or ice, that's called erosion. Weathering and erosion sound pretty similar, right? Well, yeah. But not exactly. Think of weathering as the hammer that breaks down the rocks. Erosion is the process that carries those rock fragments away, or put in a way we're all familiar with. Weathering helps make a mess, and erosion helps clean it up. Let's take a trip to the beach to see what part the hydrosphere plays in weathering and erosion. This is a picture taken from space of the coastline of Massachusetts in the northeastern United States. It's part of a landform called Cape Cod, and the picture shows what the beaches and islands around it looked like in 1984. Now look at this photo from 2014. What's different? There are actually more islands in 2014 than there were before. Back in 1984, that long strip of land was North Beach. Now, that strip of land has been chopped up into separate islands. The top part is North Beach, the middle area broke off into North Beach Island, and the bottom part is now called South Beach. So, how did that happen? Well, moving water is a major cause of erosion, and there's a lot of moving water in the Atlantic Ocean. The intense energy of ocean waves crashing on shore causes pieces of the rocky, sandy coastline to break into smaller pieces or to weather over time. Then, natural forces like major storms and rising sea levels then move or erode these smaller pieces. Day to day, you might not notice any dramatic changes, but over the course of 30 years, well, as these pictures show, coastlines can change a lot. So what can we take away from this? Well, we saw that water can weather and erode Earth's landforms, and that's just one example. There are so many others, like floods weathering valleys or glaciers eroding mountains. Let me break it down for you this way. See what I did there? The hydrosphere shapes and sometimes moves the geosphere. One last joke before I sign off. What did the geosphere say to the hydrosphere? You crack me up.
Unless you spend a lot of time underground like we do, you might not think very often about dirt. But dirt is awesome. It's everywhere. And just about every living thing on Earth depends on it, from the plants that grow in it, to the animals that eat the plants, to the animals that eat those animals. That's why we're really glad that one of our viewers, 4-year-old Caleb from Mississippi, wrote to ask us, what is dirt? Great question. First of all, the stuff that fills our flower pots and baseball fields may just be dirt to us, but scientists have a different name for it. They call the top layer that covers most of the land soil. So what is soil? Well, it's a mixture of things. How soil looks and feels depends on where you are. So some very dry places have a lot of gritty sand in the soil, while soil in other parts of the world might have hard rocks, soft clay, or even pieces of seashell in it. Usually though, soil is made of 4 main things. Mostly, soil is made up of minerals. Minerals are hard, stony substances that form things like rocks, sand, and clay. The next big part of soil is water. That's right, even if a clump of dirt doesn't seem like mud to you, it actually has water in it. All living things need water to survive, and soil does a great job of holding on to water for plants, animals, and other things that live in it. And you know what else is in the soil that you probably can't tell is there? Air. Just like water, air in the soil is important because living things need air too. It fills the spaces between all those little bits of minerals, water, and other parts of the soil. And the beauty of it is, the animals that live in the soil actually help more water and air get inside it. Creatures like worms and insects and even small mammals like moles and mice dig tunnels down in the dirt. Those tunnels let air and water trickle in and flow around so that even deep down, the soil has what living things need to make a nice home there. And this, my friends, brings us to probably the most important part of soil. In fact, it's some of the most important stuff on Earth. Scientists call it organic matter. Organic matter includes anything that's alive, like those worms and insects, but also parts of plants and even living things that we can't even see, like bacteria. Plus, organic matter also includes things that used to be alive, like dead plants and animals. After those things die, other living things like fungi, bacteria, insects, and worms eat what's left of those plants and animals and break them down into very small pieces. This broken down material puts nutrients back into the soil, and plants then use those nutrients to grow. So soil is where plants get their food. Scientists call this special nutrient-rich part of the soil by its own name, humus. Humus is what gives soil its dark brown color, and it even sometimes contains special bacteria that make soil smell, well, dirty. Now, all of these things are mixed together to make soil, but the mixture isn't always the same. Scientists have found that soil has many layers to it. The top layer is all made up of organic matter, with lots of that good, useful humus. Beneath that is the layer that we often call topsoil. Topsoil is made mostly of humus, with a little bit of minerals sprinkled in. This layer is where seeds start to grow. As you go further down away from the surface, you find that the deeper layers of soil contain more minerals than humus. And once you get through the bottom layer, you run into a layer of solid rock. So now you have the dirt on soil, and you know it's made up of minerals, water, air, and organic matter. Thank you for asking, Caleb. Does anybody else have a question? Let us know by either leaving a comment or emailing us at kids@thescishow.com. Thanks, guys, and see you next time on SciShow Kids.
We got a little dance for y'all now. It's called the topsoil dance. So put your arms in the air, put your hands up high and show me where that topsoil is. And now you're gonna learn the dance with us. All right, here we go. Topsoil, subsoil, and bedrock. Hands at the top and then the middle and the bottom, y'all. Topsoil, subsoil, and bedrock. Now listen up, now I'm gonna tell you. They call it topsoil, 'cause it's found at the top. It's a natural product of subsoil and bedrock. It's the best for growing plants, so let me see you move your body to the topsoil dance. Topsoil, subsoil, and bedrock. Sing it with soil, sister. Topsoil, subsoil, and bedrock. And move your hands to show me all those layers now. Topsoil, subsoil, and bedrock. You got soil, yeah. Topsoil, subsoil, and bedrock. But that's not all that I want you to know. There's also subsoil. It's the next layer is the bedrock deep in the ground. But they are not as good for growing plants, so let me see you move your body to the topsoil dance. Topsoil, subsoil, and bedrock. One of these things is not like the other. Topsoil, subsoil, and bedrock. Just topsoil is humus, and that's what makes the growing good. Topsoil, subsoil, and bedrock. Most of that humus is there in the topsoil. Topsoil, subsoil, and bedrock. Let me sing the praises, let me sing the praises of topsoil. Yeah.
Okay, so there's many different types of rocks, right? There are some that may be familiar to us, and others not so familiar. Which begs the question, why are there different types of rocks? Well, it has to do with the processes of how they are formed. And there's three main processes. There's melting and cooling, weather and erosion, and there's also heat and pressure. The first process, melting and cooling, involves the melting of rock deep in the ground. Eventually it cools and becomes igneous rock, like this feldspar. Another process is weather and erosion. Weather and erosion breaks down rock into sand and gravel that we call sediment. It eventually hardens through a process called compacting and cementation and it forms sedimentary rock, just like this sandstone. The final process is heat and pressure. Rock deep in the ground becomes soft and is eventually squeezed to form metamorphic rock, like this rock, called gneiss. These processes cause rocks to change. Igneous can turn to metamorphic, metamorphic to sedimentary, sedimentary to igneous, or igneous to sedimentary, sedimentary to metamorphic, metamorphic to igneous, and these rocks can even change back to themselves as well. So this can bring us to the conclusion that all rocks can form into any other type of rock. Whoa! And these processes, with the help of lots of time and these different patterns, form the famous rock cycle. Thanks a lot, and rock on!
All right, thanks for watching our review. This was part of our semester review. It is counting towards Unit 7, Lesson 1. That may have been marked skipped, but you can unskip it and mark it as complete. I will also double check that that gets marked as complete, but it doesn't have an assessment, so you are able to mark that. Your learning coach can unskip it and then mark it as complete for you. Or again, I will go in and double check that that's been done. So this is Unit 7, Lesson 1. Come to live class on Thursday and we will do the rest of our semester review, and we will be doing a different test than the one in the online school. That's because I don't want to test you on things you haven't learned. So come to class Thursday, mark off for this play posit, Unit 7, Lesson 1. Thank you.